Hello, everyone. Happy Tuesday and happy Valentine's Day. I hope you all are doing well. All right, so here are today's notes. The title of them are Compositions of Functions, and we are going to go straight to it. So, as I was talking to you guys last time in class, when you're working with functions, for example, f of x and g of x, there are some basic operations that you can do with the two functions. Like, for example, I'll put them off to the side. You can go ahead and take the function f of x and add it with the function g of x. You can take the function f of x and subtract it with the function g of x. You can do the same thing with multiplication, and you can do the same thing with division. So you can add, subtract, multiply, and divide functions. And today we're going to be talking about another way that you can combine functions, which is taking the composition of them. So as it says here, another method to combine functions is called a composition. Given f of x and g of x, my goodness, I can't even speak. The composite function, f of g of x, is defined as, here it is, and that's how you pronounce it, by the way. You would say f of g of x. So we have f of g of x is equal to f of g of x. And essentially what this is meaning is that rather than just having f of x, right, where we have our input just being the variable x, our input is now going to be like an entire function itself. So we're going to be taking one function and substituting it into the other. So we're working with two functions. I'm actually going to be referring to them as the outside function and the inside function. Okay, so you'll be working with two functions, and you're going to be substituting one of them into the other, and that's what's called taking the composition of functions. So we're going to go straight into an example of what it looks like to take the composition of functions. And one other thing to note, when you are working with the composition of functions, it is super important to consider and keep in mind the domain of the function, because remember, a function is only defined on its domain. So in all these questions, it's going to say, given f of x and g of x, you're going to find each new composite function, and then you need to and you must state the domain. Okay, we might need to do a quick refresher on the domain of functions in these examples. So let's go to it. Example 1. For example 1, I'm going to go ahead and tell you, given, my goodness, my brain is not working right now. So given f of x is equal to x plus 7, and then g of x is equal to x squared minus 4, we're going to first, part A, find f of g of x. And then in part B, we're going to find g of f of x. Okay, so don't get used to it always being f composed with g. Sometimes you can also take g and compose it with f. All right, so let's start up at the top in example A, where we're taking the function f and we're composing it with the function g. So again, by definition, f of g of x, that's equal to the function f, and then we're going to take the function g of x and just substitute it in for x. So rather than writing only the input x, we're going to substitute g of x. So it's going to look like this. Our f of x function is this one right here, x plus 7. So f of x is equal to x plus 7. Now, rather than writing the x here, I am going to substitute it and this x here. I am going to substitute all of that with the entire function of g of x. And well, what is g of x equal to? Well, g of x is equal to x squared minus 4. So right here, wherever I see my orange underline, rather than writing the orange underline, I am going to go ahead and substitute in x squared minus 4, because that's what I know g of x is equal to. So this is going to be equal to, well, I see another x. I am not going to write x. I am going to substitute in my x squared minus 4. And then just copy over the rest of my function of f, which is just the plus 7. So if you notice here, this is just f of x, but rather than writing the input of x, I'm substituting in an entire function, g of x, into my input. So then from here, all you got to go ahead and do is just simplify down the expression, the equation. You should notice here that the minus 4 and the plus 7 can be combined. So this will simplify down to x squared plus 3. So my function f of g of x is equal to x squared plus 3. And that's it. Now let's talk about the domain. So when you're working with the domain of the composition of functions, what you first need to find is the domain of the inside function. So find the domain of the inside function, and then after you have that domain, you have to then look at your final composite function, which was this one down here, x squared plus 3, and then consider that domain. Remember, when we're working with these two functions, a linear function and a quadratic function, the domain is all real numbers. So in this case, my domain of the inside function is all real numbers. The domain of my composite function is all real numbers. So the domain in general would be all real numbers. Okay, if you need a quick refresher on the domain and range, the only time the domain and the range of functions is not all real numbers is whenever you are working with a rational function, which has something like this in the denominator, because you remember our denominators cannot equal 0. And then the only other time where we need to restrict our domains is whenever we are working with even radical functions, because remember, in these, what's under our radical has to be greater than or equal to 0. Okay, so if you're not really working with any type of rational or radical function, then you can always assume that your domain will be all real numbers. Okay, so that's a quick little domain recap in case you needed it. Okay, so let's go now and try to find g of f of x. So remember, g of f of x by definition is equal to g composed with f of x. So your outside function in this case is g, your inside is f of x. So in our function g of, let's first just copy out down g of x. What's g of x equal to? Well, we know g of x is equal to x squared minus 4. And our function, g of x, wherever I see an x, rather than writing my input of x, I am going to input the entire function of f of x. So this is going to be g, trying to color code here. This will be g of, rather than writing x, I'm going to substitute in f of x. What is f of x equal to? X plus 7. So this will be x plus 7. Is equal to, I see another x, so I'm not going to write x. I am going to go ahead and substitute in f of x, which is x plus 7, close those parentheses, squared minus 4. So take a second, look at it here. I have my function g of x, but rather than my input of x, I substituted in the entire function of f of x. Okay, once you do that, then you just go ahead and simplify down your expression. Now, what is x plus 7 squared? Well, if you FOIL it out, you will get x squared plus 14x plus 49. and then I just copy down my minus 4. I notice that my 49 and my minus 4 can be combined. So my simplified down expression is x squared plus 14x plus 45. And that is what g of f of x is equal to. That is what my composition of function is equal to. Now let's go back and let's state our domain here. My domain, you have to always look at the domain of the inside function first. So the domain of f of x was, well, it was a linear function, so we know it's all real numbers. The domain of my composite is just a quadratic, so it's also real numbers. So in this case, there's nothing to exclude. So my domain in general would be all real numbers. All right, we're going to go ahead and do one more example and we're going to make these functions a little bit more complex. Example 2. Let me go ahead and give you guys something a little bit more difficult. Let's try this one. Given that f of x is going to be equal to 3 minus x, and g of x is going to be equal to x over x plus 1, we are going to first part A find f of g of x. And then in part B, we will go ahead and find g of f of x. All right, so let's start off with the top. Again, by definition, f of g of x is equal to f of g of x. Let's go ahead and find the composition here. So I am going to start off by copying down my f of x function, but rather than just substituting in x, I am going to substitute in g of x. So this will be equal to 3 minus, rather than writing x, I am going to substitute in what I know g of x is equal to, which in this case is x over x plus 1. All right, now I just need to go ahead and simplify this down. What's going to probably be the most difficult thing for you here is just remembering how to subtract fractions. Obviously, these fractions are a little bit complex. In order to change that whole number of 3 to a fraction, you can put it over 1. In order to continue from here, you need a common denominator. They definitely do not have a common denominator right here. You should be able to realize that we can take this fraction and multiply it by x plus 1, both to the numerator and the denominator, to get a common denominator. So I am running out of space here. I'm going to erase this and then just put it off to the side after. So this will be 3 times x plus 1 over x plus 1 minus x over x plus 1. Now I have my common denominator, so I can go ahead and just write it as 1 fraction bar, and then this will go ahead and distribute out here. This will give me 3x plus 3 minus x. The 3x and the minus x can be combined to a 2x plus 3 over x plus 1. This can no longer be simplified, and this is what the composition of functions looks like. So my new function f of, g of x is defined as 2x plus 3. Now what we need to go ahead and state is the domain of this function. Again, to find the domain, you first need to find the domain of the inside function. Then once you have that domain, that is automatically going to be excluded from your domain if there's something that needs to be. And then you have to look at your new function, and if there's something from here that needs to be excluded, then you also need to include this. So let's look at the domain of our inside function. Well, the domain of our inside function is x over x plus 1. In this function, we do have a rational function. So what value of x will make this denominator equal to 0? Well, we know -1. So I cannot substitute a -1 into this function. If I do, I would get 0 in my denominator, and you can never have 0 in the denominator of a fraction. So I know for sure in this domain, it's going to be all real numbers. However, you have to exclude x cannot equal -1. And that's just because of my inside function. Now let's go ahead and look at the composite. In our composition of functions, what value do I need to exclude from here? Well, in this case, you notice that it is also sorry, I put the negative right there. It is also a -1. So that just for sure clarifies, or I guess seconds the idea that x cannot equal -1. But let's just say, for example, if I got a different number here, then you would also need to add that second number in our domain. But in this case, since it's the same number, you would just say that the domain is all real numbers, but you have to exclude x is equal to -1. Alrighty, so there's that one example. We're going to go ahead and do one more, and then we will be done with these sets of notes. Okay, part B. What did I say we were going to do? Oh, yes, g of f of x. So by definition, that's taking the function g and then substituting in f of x. So let's look back at my functions. That is an x over an x plus 1. So rather than writing an x, I need to substitute in f of x, which is 3 minus x. So this will be 3 minus x over another 3 minus x. And ideally, when you substitute in, you are supposed to put parentheses around it. But in this case, since there's really nothing that's happening with that x, you don't really need them. And then just make sure you copy over your plus 1. So again, understanding that this is the function g. However, rather than writing your input of x, you're substituting in an entire function f of x. All right, so it looks like this. Now you can go ahead and just simplify this out. It looks like at the top, there's nothing I can simplify out. In the denominator, my 3 and my plus 1 can be combined. So I would get a negative, I would get like a 4 minus x. Or you could have thought of it as a negative x plus 4, whatever. All right, and there's nothing else that you can do here to simplify this down. So this is your new function once you've taken the composition of g of f of x. Now, what's the domain of it? Well, let's first look at the domain of the inside. Now, in the inside, it was just a linear function, 3 minus x, so we know that the domain is all real numbers. Okay. Now, let's see if there's anything we need to exclude. Well, over here, we know that the value of x that will make our denominator equal to 0. By the way, guys, I'm so sorry. In this example, I just realized that I put a 0 there. That should have been, I put a 1. That should have been a 0. Oops. Anyway, okay, I hope that didn't confuse you. So going back here, let's go ahead and subtract 4 to both sides. And then you get negative x is equal to -4. Divide both sides by -1. And you realize that x, at the value of x equals 4, you would get a 0 in the denominator. So that is indeed the value that we're going to need to exclude. So our domain would be all real numbers, but we have to exclude x, but x cannot equal 4. Okay. Alrighty, I don't know how long this video turned out to be, but I hope that was clear. The other thing that you can do with functions when you're taking the composition of them is evaluate them at a specific input. I am going to go ahead and create a very short, hopefully, video right after this one for you guys to watch on that. Let me know if you have any questions. If not, these are your notes on the composition of functions.